So I think we are live. Let's start. Welcome all to an official event of the International Moon Day 2025. Thank you all for joining us to a panel discussion with 4 renowned experts of the Moon Village Association's Global Expert Group on Sustainable Lunar Activities. For the next hour, we are going to leave Earth and turn our attention to the Moon. More specifically, towards sites of scientific interest on our celestial companion. To start off, we are going to hear welcome remarks from the president of the Moon Village Association, as well as the chair of the IMD group. Please play the video. I think it's going to take some time while the video loads. And while that's happening, I would kindly ask everybody to see that you're muted. And if you want, you can turn on your video. Thank you.
Greetings, everyone, and welcome to the International Moon Day Global Celebrations. I am Nasr Sahaf, chair of the IMD group. Since the inception of the IMD through a declaration in December 2021 by the United Nations General Assembly, the IMD has been celebrated worldwide every year in more than 50 nations. Every year since 2022, there is a theme. Then it was lunar exploration, coordination, and sustainability. In 2023, it was beginning the new lunar journey. In 2024, it was illuminating the shadows. And this year, it's one moon, one vision, one future. IMD is a special opportunity to raise awareness and educate the public on the status and prospects for humanity's exploration and sustainable activities on the moon. IMD events foster increased global awareness, cooperation, and coordination among stakeholders worldwide, and promote increased participation towards this goal for future generations. Our main event this year in 2025 is held at the University of Dubai in the United Arab Emirates, home of the Mohammed bin Rashid Space Center and the UAE Space Agency in Abu Dhabi. I wish you all a very successful IMD global event in your country, wherever this may be. Thank you and God bless.
So good morning, good afternoon, and good evening to everyone. I am Giuseppe Reibaldi, and I'm the president of the Moon Village Association. Let me first of all thank all the organizers around the world for being part of the International Moon Day and for all the events that they are organizing. The Moon Village Association is an NGO which is registered in Vienna in 2017 and is acting as a unique platform to bring together space agency, government, industry representative, academia, international organization, and the public to discuss and conduct peaceful lunar exploration and utilization. It is a unique organization, and we had developing several activities, which is ranging from technical to economic, as well as to culture. But many details can be seen on the MVA website. MVA is also a permanent observer at the United Nations COPUOS, and in that respect has an important function and has given strong, important contribution. And one of these contributions is the proposal to create the International Moon Day. And this has been approved in a very fast way from the General Assembly in 2021. So detail of the International Moon Day and the theme, as well as all other information related to the International Moon Day, will be delivered by the chairman of the International Moon Day, Dr. Nasser Al-Saad. So I just want to take this opportunity to thank all the participants of this event. It's important that once a year, at least, people from all the world take the time to discuss within themselves and with the public what does it mean going forward to the moon, and what does it mean for humanity to harvest resources of the moon in a fair and sustainable way. Thank you, and I wish all of you a happy International Moon Day.
I posted. Oh, please make sure that you're muted. Thank you. Thank you to both of our distinguished speakers that just gave the welcome remarks. I posted a link to the main event, which is going to take place in less than 24 hours. So if you want to, you can watch it live on YouTube. And I also posted the link to the Moon Village Association. I just saw that there is a question. In the end, you will get a certificate if you're going to attend. In the last few minutes of this hour, I'm going to post a link to a form which you can fill out. And then at the end, you will get a certificate. Now let's jump right into what we've been waiting for the whole time, the panel discussion. And I'm going to introduce our 4 experts. And let's start with ladies first, with our chair of the Working Group on Lunar Environmental Protection, Alice Gorman. Alice is an international recognized leader in the field of space archaeology and author of the award-winning book, Dr. Space Junk versus the Universe, Archaeology and the Future. She's also an associate professor at Flinders University and a heritage consultant with over 30 years' experience working with Indigenous communities in Australia. In 2024, she was elected as one of the Explorers Club 50 people of changing the world that we need to know about. And then we have Farah. She's the co-chair of the working group. She works for the Indonesian House of Representatives as a legislative drafter. Farah has been involved in almost 100 programs or projects, holding active leadership roles for the youth and space sector. For example, at the Space Generation Advisory Council. May I also introduce Ian Grafford. He's a renowned professor of planetary science and astrobiology at Birkbeck College, University of London, in the United Kingdom. His research interests include lunar science, space exploration, and the search for life in the universe. In 2023, he was presented with the prestigious Michael Vargar NASA Exploration Science Award. And finally, may I introduce Jean-Claude Worms. He is the Executive Director of COSPAR, the Committee on Space Research, and former CEO of the European Science Foundation, ESF. He holds a PhD in astronomy and space science and has more than 30 years of experience in space research projects, science management, and space policy. Now we are going to hear presentations from our 4 panelists. So again, kindly make sure to mute yourself during their presentations. Afterwards, you're going to have a chance for a Q&A with them. And in that case, you can also already think about which questions you want to ask them. Thank you so much. And now I'm going to hand over the floor to Alice.
Thank you, Anna, and may I wish everyone a very happy International Moon Day tomorrow. So while I'm sharing my screen, I want to tell you that I'm joining you from the lands of the Kaurna people of the Adelaide Plains today. Offer my respects to their elders, past and present, and also my respect to any traditional owners who are joining us in this meeting here today. So I'm going to do a brief introduction to our main topic today, sites of special scientific interest on the moon. So this is a term that comes from the UK Wildlife and Countryside Act. And by sites of special scientific interest, they mean places that have interest because of their flora, fauna, their geological or their geomorphological features. And while this is a specific act in the UK, most countries in the world have some kind of piece of legislation that identifies and then protects sites which have natural heritage or scientific significance. So in 2024, sites of special scientific interest were proposed for the moon. And this proposal came from a consortium of organizations, including the Moon Village Association, COSPAR, the Committee on Space Research, the International Astronomical Union, and the International Academy of Astronautics. So this proposal was taken to the UN, where it was met with some approbation. So to go a little bit deeper into what we mean by this, scientific interest or scientific value is one of a number of kinds of value that we accord to places, to cultural or natural places, mostly on Earth at the present time. And these types of value include historic, social, aesthetic, spiritual, and scientific. And it's the scientific that we're focusing on today and for the moon. So what does it mean to say that something has scientific value or scientific interest? It's basically about the kinds of research questions that we can ask of a place or ask of the features present at a place. And perhaps even more important than that, it's what kind of research questions we can answer by carrying out studies or investigations of this particular place. And for the moon, we have to also ask the question, what can we no longer ask or answer if a site of scientific interest is contaminated, compromised, destroyed, or disturbed in some way? What happens to our knowledge of the Earth, the moon, the solar system, and the galaxy if we lose access to these places for these reasons? And this includes two levels. So we have the actual places themselves that we're interested in, but there are also places from which certain kinds of science can be carried out, which Ian will talk a little bit more later. So it's what we can do in that place that gives it special scientific interest. So I'm going to give you a few examples of places like this on Earth. So the first one is the UNESCO Global Geopark in Norway that's called just simply Magma. The UNESCO Global Geoparks are a number of places across the world that have outstanding geological value. In this case, the Magma location tells us a lot about early volcanism on Earth. It spans the last ice age right up to the present. And it is very similar to the moon, interestingly. So one of the primary mineral deposits there is anorthosite, which we also find in huge quantities on the moon. So this is a place on Earth that can tell us something both about the Earth and about the moon. Another place, this time it's on the actual World Heritage List set up by the World Heritage Convention. This is in South Korea, the Jeju volcanic island and lava tube. So this is significant again because of what it can tell us about volcanism and these very specific kinds of geological formation, the lava tube, which we're also interested in for the moon. The picture down below is an actual site of scientific interest as identified by the UK Act. This is Dark Peak in the UK. This is a large area which has distinctive geological formations. It has distinct heath, bogs, meadows, and other vegetation communities. And it's also well known for its birds. And in terms of cultural values, its remoteness and tranquility are part of the significance of this site. And the picture I've shown you here is Shining Tor. Shining Tor is so high it was likely above the glacial ice sheets in the last glacial maximum about 40 to 30,000 years ago. So as a geological formation, it would have been pretty stunning. Finally, a place from Australia. This is on Australia's National Heritage List. It's Arkaroola in the Flinders Ranges, and it's actually used as a Mars analog research landscape. But what gives it this distinct scientific interest is that it's a radiogenic landscape. It's filled with uranium, thorium, and other radioactive elements that mean the geological processes there are actually impacted by radiation. So these are the kinds of places that we have on Earth that we provide protection to for their scientific value. And you can imagine there are many, many, many others. Each nation will have its own at local, regional, national, and World Heritage level. So this is basically what we are proposing for the moon as well. And one of the reasons we've made this proposal is because the scientific interest or value of places on the moon is going to be under threat in the medium to long-term future by activities that take place on the moon. So these include things like dust transport, which will move dust around at a much higher rate than it already moves, confusing the geological record. The surface of the moon is not static. It is shaped by a process called impact gardening. Micrometeorites, cosmic rays, high energy particles that come from space. Soon there will be an anthropogenic component to that as well. We have potential contamination by terrestrial waste, whether that comes from a rocket or from an installation on the surface. We are potentially looking at the destruction of landforms or landscapes from resource extraction or in situ resource utilization, as it's called, local use of resources to support industry or settlement. We may also get disturbance to the integrity of cultural heritage sites and radio interference, which will prevent radio astronomy from taking place. So what kinds of places might be sites of special scientific interest? I won't go through this list here, but you can see there's a lot of different things that we might decide has special scientific interest. This includes places which might contain prebiotic molecules that can inform us about the emergence of life on Earth, places that relate to the origins of the moon, or to the chronological periods of the moon, which unlike on Earth are actually pretty sketchy. They're not very well resolved. And we can even learn something about Earth's history and climate from places on the moon. So this is just to give you a background to why we are proposing sites of special scientific interest. And I'm now going to hand over to our second speaker to go into more depth about this topic. Thank you.
Okay, so hello everybody. I believe I'm the next person. Anna, am I the next person?
Yes, that's correct. Thank you so much.
Thank you. So I'll just hopefully everyone can see. Can you see this?
Yes, yes.
Okay.
It's
So
great.
yeah, thank you, Alice. So I'm going to just talk briefly about some specific sites of scientific interest that we believe are on the moon. So there are several of these, and Alice had them in her list. I want to start with the lunar polar regions. So this is a beautiful image. This shows the south pole of the moon, taken by Japan's Kaguya spacecraft. almost 20 years ago now. This is the south pole of the moon. The geographical south pole of the moon is there, just near where the red pointer is. On the rim of this is a 20-kilometer diameter impact crater called Shackleton crater. And since this is the south pole of the moon, if you look at the Earth apologies to Alice, from a northern hemisphere perspective, the Earth looks upside down because the south pole of the moon looks the right way up, and indeed here is the continent of Australia. Now, if you look at this picture of the south pole of the moon, there is a lot of shadow. And there's a lot of shadow because the sun is always on the horizon at the south pole of the moon, which means the floors of craters like Shackleton crater here never see the sun. So this means they're extremely cold, and they're the only places on the moon where water ice is thought to be stable. So we believe these craters on the south pole of the moon contain water ice, probably water delivered to the moon by comets and asteroids over the history of the solar system. Now, this ice, if it's present in these craters, is of great scientific interest because it preserves a record of the delivery of ice and possibly also organic compounds to the moon, of course, but that's also a record of the delivery of materials to the Earth-Moon system, and therefore it's a record of the delivery of volatiles to the Earth as well. So it's important for the scientific community that we study this ice before it becomes contaminated by rocket exhausts, for example. So this ice is also of commercial interest because ice will be a very valuable material. Water ice will be a very valuable material when it comes to exploring the solar system because it's a source of water on the moon and also a source of hydrogen and oxygen. So there are already commercial companies interested in mining water ice from permanently shadowed craters at the lunar poles. And yet it's important that as that activity starts, it doesn't destroy or contaminate the record of these ices that we wish to study for scientific purposes. So this is one example of a site of scientific interest on the moon. This picture just shows the distribution of craters that are in permanent shadow, the so-called permanently shadowed regions. That's the acronym PSR, permanently shadowed regions. These are craters that the floors of which never see the sun. And you can see there are several dozen of them, but there aren't an infinite number of these permanently shadowed regions on the moon. So I think, and Jean-Claude will talk about this later, that there's an important policy issue here to try and decide which of these permanently shadowed regions should be preserved for scientific investigations and which ones could be given to the extraction of water ice as a potential resource for future human activities. The next scientific site of scientific interest on the moon I want to talk to briefly is the lunar far side. Now, this is a nice image. It's taken by China's Chang'e 5 T1 spacecraft in 2014, and it shows the Earth in the background, of course, and it shows the moon. But this is the far side of the moon. So the spacecraft, when it took this image, was above the far side of the moon, which is a part of the moon, the side of the moon that we can never see from the Earth. But because the far side of the moon, so this region here, because the far side of the moon never sees the Earth, it is shielded from all of the artificial radio traffic that we generate on our own planet. And so this means the far side of the moon is the most radio quiet place known in the solar system because it is permanently shielded from the Earth. And for the lunar, when it's lunar nighttime on the far side, it's shielded from the sun as well. So during the lunar night on the far side, then there's the two strongest sources of radio emission, natural and artificial, in the solar system are below the horizon, making this the quietest place for radio astronomy anywhere that we know of in our solar system. But if the far side of the moon is to be preserved for radio astronomy, this requires the development of international regulations or international norms which will keep the far side of the moon radio quiet. Because if we start polluting the far side of the moon with radio interference, it will cease to be the best place in the solar system for radio astronomy. And then finally, just one other example of potential sites of scientific interest on the moon that Alice alluded to. These holes in the ground on the moon, these are not meteorite craters. These are places on the lunar surface where the surface has collapsed. So these are called collapse pits. But in order for the surface of a planetary body to collapse, it means there has to be a hole, a space, a void space below the surface. Probably natural caves produced by flowing lava long ago, and such caves are called lava tubes. And Alice showed a picture of a lava tube on the Earth. These will be unique geological environments. We haven't explored them at all yet. We know they exist, but they're another example of a place on the moon which it will be important to explore before their unique natural environment becomes disturbed by human exploration. Okay, thank you, Anna. That's the end of my slides, and I'll just try to stop sharing. Okay.
Thank you so much.
Who's next?
If you want to, you can go next.
Oh, okay, thank you, Anna. Okay, hello everyone. Jan and Alice before have explained why it's important to identify, designate, and protect lunar sites of special scientific interest. And they did mention it, but I just recall it. There are three categories of such sites. Permanently shadowed regions, PSRs, as Jan described, uniquely suitable locations for astronomy, as he also talked about, low and stable temperature far side of the moon, and unique scientifically significant features, meaning lava tubes, for instance. And the question is now how to enable this designation and preservation process, meaning how do we ensure that it is agreed upon by all and made enforceable? And the last part is equally important. What's at stake here from the perspective of scientists and all the stakeholders involved in lunar exploration and use? I would argue, and maybe some scientists would disagree, but that the case is about protecting future science while enabling space exploration and use of resource. And I don't think there is any other way. Scientists will not be able to fight commercial interest even if they wanted to. Look at the way the International Astronomical Union has managed the matter of dark and quiet skies. It's by talking to industry and trying to find solutions together. So we need to discuss with the non-scientific stakeholders, industry, policy, legal, at the national and international level. We need to issue recommendations, obviously, to agencies, governments, and the United Nations Committee on the Peaceful Use of Outer Space. There is an urgent need, as pointed out by Ian just now, to identify best practices about how to work on the moon and adopt guidelines and possibly regulatory frameworks in the cislunar region and on the moon for site identification and preservation, but also other aspects in the cislunar space like collision avoidance, passivation of upper stage of rockets, spectrum management, etc. Let me give you an example of a governance issue that could appear for a PSR at near a lunar pole. These PSR, as Jan mentioned, can be of interest to multiple entities, commercial companies or agencies wishing to extract water from ice deposits, to use it or sell it to private and governmental entities operating elsewhere on the surface. Astrobiologists working on volatile and organic molecules delivery to the Earth's moon system from the outer solar system, and that could be compromised by inorganic rocket exhaust products or space mining if it ever takes place there. Astronomers using the cold and stable environment of PSRs to establish an optical or infrared telescope to study, for instance, exoplanets or gravitational waves, that could be compromised severely by dust, for instance, or vibration by nearby mining. So who decides who has priority to do what and for how long? And this is really the key matter here. There are multiple actors involved. We need to think about a way forward encompassing all those actors. The concept, as Alice was pointing out, of SSSI has been introduced formally at the level of UN COPIOs by COSPAR, MVA, IAU, and IAA in February 2025, and again in June this year. But there are also a number of other stakeholders and non-governmental organizations that are also observers to UN COPIOs that are part of the discussion. and all should speak with one voice. Lunar Policy Platform for All Moonkind, Lunar Open Foundation, Secure World Foundation, etc. We should find a way to involve everyone in a forum that is yet to be determined through a formal process that is yet to be determined. And for that, we need to secure formal support from UN delegations, a maximum number of UN delegations. One of the initiatives that we have arrived at already is to set up a group of friends for SSSIs that will be announced very soon in the next few days, where most of the above-mentioned NGOs will participate, but also a number of delegations in UN COPIOS have already indicated their interest. I will not mention their name at this stage. It's not official, but they will participate. So we are moving forward in the right direction. What kind of process can we envisage? Should it be a new international treaty? I know there are questions out there in the crowd listening to this panel that are mentioning international regulation. Can we have a new treaty? Probably not. It's probably not doable in today's concept to have a treaty. It's extremely long and complicated. And if not a treaty, what can be the role of the United Nations? Should it go through national legislation? But then why only involve those nations that have a space legislations that are not even harmonized throughout the globe and do not necessarily recognize the primordial value of science in the process? Should it be through multipartite accords like the Artemis Accords or the ILRS? But then why only some countries, while the moon is a province of all humankind? And yet this may be the only pragmatic way to do it. The last part is what Jan alluded to. We need to find a set of best practices and agree on an operational framework that is internationally agreed upon. And then the key question becomes, I think this is achievable, but the key question then becomes, who will ensure that this internationally agreed upon framework will be respected, under whose authority? And again, the UN should have an important role here. In terms of approach, the identification and preservation of SSSI cannot just be done for all eternity. It has to be associated with a timeline for each category that I mentioned. In other words, it's not just the why and the where that are important, but it's also the when and for how long. And this, regardless of the fact that I said we should all talk together, this part is a scientific process. It cannot be delegated to others. It needs to be fed as a recommendation to the other stakeholders. And the science community, I believe, has a strong responsibility to agree on such a roadmap in the short term, meaning that we should aim at having an international event in 2026 where all the concerned scientific stakeholders meet and agree on a path forward and a set of recommendations for the decision makers. As was mentioned at the beginning, this year's theme for the IMD is One Moon, One Vision, One Future. It's very appropriate for our topic today because SSSI require basically everyone to have one single goal, explore and use our one and single moon in a sustainable manner. The status of our activity and the recommendation, first we need a snapshot of the lunar surface across multiple forms of sensing before human activity alters it. Alice said that. Scientists should partner with industry to gather scientific data alongside commercial prospecting. We need a detailed planning to protect the moon's scientific value and establish clear area for scientific reserves. We need guidelines, as I mentioned, regarding the duration of protection for each site, which depends on the scientific applications you envisage there. And therefore, COPIOS needs to establish a stage designation process. We need to have a greater understanding of the requirements and impacts of a water-based lunar architecture, because water, as yet mentioned by Jan, is the focus of many missions and many near-term and long-term plans and activities. We need to be able to prevent radio interference on the far side through careful satellite design and frequency allocation. And it's not clear yet what Earth-based bodies could do that. It's not yet the case. And finally, COPIOS probably needs to consider establishing a nomination committee for SSSI. Thank you very much.
Thank you so much. And to our final speaker, I'm going to hand over the floor to Farah.
Okay. Can everyone see my screen?
Yes, we can.
Amazing. And before we go further, I saw Giuseppe is joining us, so welcome to Giuseppe, our president at Wind Village Association. Yes, hold on. Okay, amazing. Hi, everyone. I'm Farah. And to ensure we have a similar reference and understanding of what kind of perspective I want to deliver, I've just sent a link in the chat box. You may find on the hold on. You may find on the page 5, number 3, that SSSI has possible tensions with the other lunar activities, especially in situ resource utilization. Here, I want to answer these tensions with coordination policy approaches, outlining how each country can serve as a balancing control to the others in regard of their capabilities and rules. Here, I want to propose a binding instrument or hard law, as Jean-Claude said previously. I reckon recommendation will work well. We can still visualize humankind's collaborative effort on the moon, including the SSSI activities. However, at the same time, we should also recognize that the country's ego does exist, as seen in the moon race and the desire to be the winner. And this is not a bad thing nor a bad influence, actually. Every country has its right and its sovereignty to become the number one, as long as it doesn't violate others' rights and sovereignties, because those rights and sovereignties bear responsibilities to be considered as a good party and correct action. Yes, I would propose 3 stages for the SSSI or SSSI coordination policy. And the first stage is pre-implementation. I assume you are familiar with the Moon Agreement if you are a Moon folk. Otherwise, if this topic interests you recently, you may take a brief explanation on the next page, page 6, in our Moon Village Association report. There you could find in Article 7, Paragraph 3 of the Moon Agreement stipulating a mandatory action, because I say it's a mandatory action because it says so, to report areas with special scientific interests and designate the areas as international scientific preserves that have special protective arrangements. Then it also states that to be agreed upon in consultation with the competent bodies of the United Nations. What we can do here is exactly what GEXLA has been doing so far. GEXLA has a Lunar Environmental Protection Working Group, and we actively propose recommendations to the UN via Moon Village Association reports. And this idea was brought under Ian and Jean-Claude's leadership before Alice and I. And we involve members with various nationalities with distinctive countries' perspectives and conditions. And then about the UN can consider forming a working group on the SSSI, as happened with the long-term sustainability proposal in 2010. Then they produced guidelines which were adopted in 2019 under the competent bodies called COPOS with the help of UN-USA. And yes, we could do the same with the UN Working Group on SSSI, addressing a call to action to produce related projects and get involved in the activities. We can also expose more possibilities like establishing an international regime as mentioned in Article 11, paragraphs 5, 6, and 7 of the Moon Agreement, as it also mentions about international scientific community. Then in implementation stage, if I may calculate, we won't be using this recommendation effectively for 15 to 20 years. But something that we can focus on is how to involve everyone in the activities there without leaving commercial aspects, environmental impacts, and research targets. As said in this document, we can allocate different permanently shadowed regions or PSRs for different activities under active observation and management of the SSSI working group that consists of diverse countries' space capabilities and missions. Because by understanding the capabilities, we can determine the proper mission for them, for our country. And the international regime, of course. Last but not least, about the post-implementation, it's all about reports or updates, and of course, observation. The moon's unique environment, sorry, am I audible?
Yes, you are audible.
I'm sorry. My screen was freezing. Okay, so about the moon's unique environment, the report from the states or state members shall not be given annually, but at every time they complete each item of their activities. Here, countries can remind each other by sending a letter or through a reminder notification from the working group, SSSI working group. Because if we let the states report their activities annually, we'll go there to fix these mentioned issues or tensions here as mentioned in our document, like rapidly. Yes, you can observe the condition with advanced technology, but to take action to solve the issues, it takes time. Many advancements on the moon have just happened lately, and we are still counting for the next advancement, right? And I want to mention dispute settlement in post-implementation because I'm focusing on the policy coordination, not on legal approaches, especially in hard laws. But yeah, that's my perspective. I hope it helps. Back to Anna. Thank you, everyone.
Thank you. This has been a fascinating presentation from all of you, and now we are going to go into the Q&A. What's important is we only have 10 minutes for the Q&A, so please keep your question very precise, and I'm going to make sure that there is one for each of our panelists. So, is the first one, we received also a lot of questions actually from you when you signed up. So there's one that was very interesting from someone about dust plumes, and I'm going to direct that question to Alice. It was asked whether the dust plumes from lunar mining activities or other activities on the moon are likely to cover up the Apollo 11 footprints, and if yes, how can we protect them? For example, with a dome or other measures. Alice.
That's a great question. So we know that the blast from the ascent vehicles from the Apollo missions was not sufficient to blow away the footprints. You can still see them from the Lunar Reconnaissance Orbiter. But if there's a lot more activity on the moon and lunar dust is highly transportable, it is possible that they will be abraded, covered up, or even blown away. Now, NASA has written a set of guidelines in 2011, which has a lot of instructions about how to overfly or approach in a surface vehicle or rocket in order to minimize the amount of dust that is going to get blown over or blown up. But there is this risk. A dome is it's been proposed before, but in order to place the dome, you may cause just as much damage as you're hoping to prevent. And the key thing here is that we don't have a full record of all of the footprints, vehicle tracks, and traces left by those human missions. So before any form of heritage management is proposed, we really do need to study them in much more depth than we currently have.
Thank you, Alice. And I feel like this brings us to another question that was sent to us about, well, how can we ensure with the processes that you mentioned, for example, Jean-Claude, that all actors actually gather around the table? You mentioned how there are many different groups who have interest in this. How can we connect them? And how can we make sure that everybody's voice is heard? Jean-Claude, maybe if you want to take that question.
I can try, although of course, I don't have the answer, especially to the question of whether we can actually ensure that everybody will be around the table. That part should be perhaps the easiest one. The most difficult part is to make sure that parties agree on a given set of guidelines, agree on a regulatory framework, and find the ways to both implement and enforce it. To me, and Farah addressed some of these aspects, but to me, the implementation, of course, is already difficult, but the enforcement is even more difficult. How do we make sure there's no police out there, there's no military out there? If we have a set of guidelines, how do we make sure, except by the goodwill of the actors involved, that they will be respected? So that's the key question for me. But of course, we have to take these matters one by one. And the first step to me is, and at least the responsibility of the science community, is to assemble some kind of forum next year so that we gather the maximum numbers of concerned actors so that we can start the discussion and make sure that everybody's voice is heard. That's the only thing I can say at this stage. I can offer no guarantee, of course.
Thank you, Jean-Claude. And I can see two questions in the chat. The first one, maybe that's something you would like to take, Ian. It's about what types of lunar areas are currently being evaluated as priority zones for protection, and what scientific, cultural, or aesthetic criteria are being applied. Maybe it also goes a bit to you, Alice, but maybe you, Ian, would like to answer first.
Well, yes, thank you. I mean, this is a very important question, and in fact, this is really the key question. So I think we've already identified in our work the top level classifications as the permanent scientific, the permanently shadowed regions with their ICES of scientific interest. There's the lunar far side for radio astronomy, and then there are the unique geological locations like the lava tubes. So at a generic level, I think we've already identified them. But then it comes down to the specific ones. Which permanently shadowed regions should be preserved? Which areas of the far side should be kept radio quiet? Which lava tubes should be not visited until we've learnt more about them? So this is where the process that Jean-Claude has already alluded to becomes crucial. We need the scientific community to come together in an internationally recognized forum of some kind. I do think COSPAR is the obvious body to lead this. To make specific, detailed recommendations that can then be passed up to policymakers and governments. And I think as a scientific community, anyway, that's our role.
Thank you. Is there any of the other panelists who would like to add something to that? Otherwise, I would... oh yeah, Alice, please.
Alice on culture and aesthetics, maybe.
Yeah, exactly.
Well, I was going to say we do have the lunar environment is very unique, very different to Earth, and so there's a lot of stuff that we will have to kind of devise anew. But we do have good terrestrial processes and precedents that we can build on. And I think this means we're not starting from nowhere when we begin the process of international consultation and gathering together all of the interested parties. And I think we should definitely learn everything we can from those processes. And I'd also just mention, I hope that heritage sites have scientific value also. So I hope that we'll be considering those in the discussions around this.
And yeah, exactly. I would say that also answers the next question that was posted in the chat. And maybe one to you, Farah, because you proposed 3 very interesting steps. And I wondered, since you're focused on policy and binding instruments recommendation, how effectively would the recommendations be implemented to SSSI projects? Because from one step to the other that you mentioned, the implementation itself, what do you think about that?
Thank you. So I do think that soft law, such as a recommendation or guidelines, will be far effective instead of the binding instruments, because binding instruments is very rigid. And when we talk about soft law, we can take action without revising the substance. We can it has more flexible substance, so we can interpret it in different actions without worrying about, am I violating the formula, the stipulation or not, or otherwise, something like that. So yes, it will be more effective, but I could say that it will be fully effective in around after 15 to 20 years of the implementation, I guess. Fully effective, I said. But if it's only about the project involvement, engaging emerging countries with leading countries or nations in SSSI projects and research before we really implemented, identifying, allocated the location. Of course, it's possible. So yes, soft law will be better for SSSI, because we are managing people with different capabilities and interests, of course.
Thank
That's
you.
my understanding.
Thank you. I can also see that Jean-Claude has his hand up.
Thank you, Anna. This just reminds me of something I wanted to say, and what Farah said is important. I agree with her. Soft law, I think, is the way to go. She also mentioned the Moon Agreement as one guide for our actions, and it's a guide. It can be nothing else at this point for everyone who has dealt with the subject. You know that there are only, I think, 4 states that have signed the Moon Agreement. And none of the major space powers have signed or ratified it. So it's not as if we would be in a position to implement the Moon Agreement, because if we were able to do that, as Farah was saying, the right wording already exists there, but nobody has signed it nor ratified it. So we cannot use the Moon Agreement as a treaty. However, we can use some of the provisions in the Moon Agreement to substantiate the formulation of soft law, the agreement on a potential operational framework and best practices. So I think that is really the way to go. If we look at the way COSPAR has managed planetary protection, which is about biological contamination, we have not been in a position to have a formal regulatory process, and COSPAR is not a regulatory agency. We have developed and continue to develop a set of guiding principles that are non-binding and that space agencies decide to adopt or not, which they do since 1962.
Thank you. And Alice, would you like to go next?
Yes, not in response to a specific question, but I think it's important to mention this, because this is actually some research that's been done by Ian and his colleagues, which show that the moon bears traces, or probably bears traces, of its passage through the solar system, through the galaxy. Like the whole solar system has moved over time. And of course, Earth is full of atmosphere and vegetation and stuff. We can't see that stuff. But on the airless surface of the moon, there will be some places where you can see what was happening in the broader galaxy at the time the solar system was moving through it. And I think that's extraordinary. And I think most of us would probably say we would not like to see those places just vanished before we even get a chance to have a look at what they mean.
Thank you, Alice. And I think that's a really great concluding phrase for our Q&A, and maybe also for this panel discussion, that we need to really protect. And as Jean-Claude said before, this is really in the spirit of this year's International Moon Day theme: one moon, one vision, one future. That this preservation of sites of scientific interest is in our all interest, every person, and that we have to work together towards it. And maybe as a final 2 steps, I would like to first ask everybody to turn on their cameras so we can take a picture. And then lastly, I'm going to share the anticipated form which you can fill out, and afterwards you will get a certificate for attending. So in order to do the picture session, thank you. Yes, I can see more and more people turning on their camera. Thank you so much. Our president, Dr. Ribaldi. Hello, thank you so much for joining us. And I'm going to take a picture now in 3, 2, 1. Thank you so much.
Thank you.
And
Thank you.
now I'm going to share the link to the Google form in the chat. And of course, you can always write to us if there are any more questions. And please follow all the other International Moon Days events. And you know that in the future, for the next year, you can also register your own event. And yeah, keep following us. And thank you so much for joining us today. Thank you so much to our 4 panelists. It was fantastic.
Thank you.
everyone.
Bye, everyone.
Yeah, thank
Bye.
you. Cheerio,
Thank
everybody.
you. Thank you.
Thank you, Anna. Thanks everyone for coming.